Welcome to the Formulas and Functions 2 participation project for the WV mining problem. Here I've downloaded and extracted from the provided data files the starter file for this project. And I've got it open in Excel. To get started, we're going to calculate the total value of the coal that was mined in each county for each year. We have data that we can use to generate that figure. On the coal mine sheet, for each county and year, we have the number of tons of coal that were mined. And over on the prices sheet, for each county and year again, we have what the price was per ton. So we can find out the total value just by multiplying those two figures. And we're going to do that by using what's called a 3D formula. When we have a normal 2D cell reference in a formula, the two dimensions are the row and column. In this case, we need to add a third dimension, and that's going to be which sheet has the data that we're interested in. We're going to fill up this table worth of data here. And if you notice, I had these spreadsheets set up so that the coal mined, prices, and total values all follow the same pattern in terms of counties being listed alphabetically and then the years incrementing. So C4 is Barber County in 1999 on coal mined and on prices and total values. So that's going to make it really easy for me to go and set up my formula here to go and calculate the total value. I'm going to go and type in an equal sign, since that's what we do to start off a formula in Excel. And I could go and type the name of the sheet that has my data. I could go and type in that I want coal mined, and you put the name of the sheet inside of single quotes and then an exclamation point, and you can go and then type in the cell reference, or you can just go and click on that cell. So actually we'll do this style reference here the traditional way for the first part of our formula, and then for the second part I'm just going to go over the prices and go and click on the cell that I want. So this table is called Table 2, and we're going to go and grab the corresponding row in the 1999 column. Go ahead and hit enter. You can see that we've calculated that there was about $34 million worth of coal that was mined in Barber County in 1999. And Excel went and automatically copied that same formula down to the rest of the table. I want to go and fill over to column G. So what I'll do is just select down from C4 through C58, and then I'll use the autofill handle that's in the bottom right corner. When I go and hover my mouse over it, it changes the cursor to that plus sign. I'm just going to drag this over to 2019. So you can see the values of the coal that have changed quite a bit from some counties. Like Barber County, it went from $34 million to $176 million, but Boone, it's now less than half. It actually peaked at $1.7 billion, but now it's just, in 2019, was down to $320 million. Next, we want to head over to the coal mine sheet, and we're going to fill out this column I, which will indicate if the county was in the top 10 for the amount of coal that was produced in 2019. We're going to use an if statement to do that. It involves the if function. We're going to write a formula here where we'll start off with the equal sign, and we're going to call the if function. The if takes three parameters that we're going to specify. The first is going to be the condition or logical test that we're going to use. And what we want to see here is if the value that's in column G, I'm just going to type in G4 here since that's the cell for this current row. And I'm just going to go and compare it against what I know to be the value of the number 10 ranked county. So I'm going to see if G4 is greater than or equal to 447,3004 tons of coal. I could go through and write this a little bit more complicated way, going through and using the rank function, rank.eq, to go and actually figure out numerically what the rank was. But for our purposes here, this is going to get the job done, and I think it'll be a little bit easier to understand this formula than the other more complex one that would be required for using rank.eq. So if the value in G4 is greater than or equal to this number, we want to go and do something. And that's going to be our second parameter. We put a comma to separate the parameters. You can see now here in the tooltip, it's now bolded the second parameter. In this parameter, we're going to specify what should happen if that test is true. And we're going to write out the word yes. So inside double quotes, I'm going to put yes. If the test is false, it's going to do what we specify in the third parameter. So I'll do another comma, and now you can see we're in this value if false section. And inside of double quotes, I'm going to write out the word no. I'll go ahead and hit enter, and you can see it's going to go and fill things out down that column. So like our first county here was Kanawha. As we scroll down, that was in the top 10. Pretty much it's corresponding, generally speaking, with the counties that are green. So this is a simple if statement where we're just checking one condition. Sometimes we want to check multiple conditions when we go and use an if statement. We're going to do this here in column J. What we're going to do in this column is we're going to display the word yes if a county was in the top 10 for any of the years for which we have data. If it wasn't in the top 10 for any year, it's going to display no. But as long as it was in the top 10 for at least 1 year, we're going to say yes. To go and set this up, we'll start off with an equal sign, and I'm going to use an if statement again. But inside the logical test here, I'm not just going to go and write a simple formula like I did where I said G4 was greater than or equal to that 4473004 number. I'm going to go and use a special function that's called OR. OR will go and return true if any of the conditions that we specify as parameters are true. So what I'm going to do here is set up a series of comparisons looking at the values in C column and D column and E column, F column, and G column. If at least one of those conditional tests I'm going to write here is true, then this overall condition that comes from the OR is going to be true. There's also an AND function, and with the AND function, all of the conditions that you specify have to be true in order for that AND to be true. In our case, though, we just want at least one of them to be true. So I'm going to specify some conditions here. Our first one is going to look at the values for 1999. So I'm going to type in C4, and I want to see if that was greater than or equal to 6764585. And then to specify my next condition, I'll go and type in a comma. This one's going to be looking at the values for 2004. We'll have D4 greater than or equal to 5143988. We're just going to work our way across, putting commas between each of these different conditions that we're testing. E4 needs to be greater than or equal to 4636665. F4 needs to be greater than or equal to 4635222. And our final condition is going to be G4, and that one would need to be greater than or equal to 4473004. I'm going to close up the parentheses for the OR function here, and you can see these parentheses are both in red just to kind of show that those parentheses are matched together. I'm going to type in a comma, and now we're back at the second parameter of our if statement. If any of these conditions are true, we need to specify what we want to do. and I'm going to write out the word yes. So I'll put that inside of double quotes, and then I have a comma so that I can do my final condition. And if none of those that I'm testing in the OR are true, then I'm going to go and write out the word no inside of double quotes. Closed up my last set of parentheses there. I'm going to hit enter, and it'll flow on down. So you can see, for example, that Boone County was not in the top 10 in 2019, but it was in previous years, and actually back in 1999 it was the highest county. So Boone County is going to show yes for the 1999 plus top 10 county because at least one of these conditions that it's testing was true, even though not all of them are. Let's go ahead back to the total value sheet. And here in column I, this 2014 to 2019 change, what we're going to do is write another if statement to go and compare the value of the coal that was mined in 2014 versus 2019. And we want to determine whether that value was increasing or decreasing. Let's go ahead and we'll just start off with cell I4 for Barber County. Just start at the top of the column. We're going to write our formula by putting in an equal sign, and then we'll do an if statement here. And we have an open parenthesis. And I want to see if the value for 2019 was greater than the value for 2014. So I can type in G4, or I can just go and click in that cell. And I want to see if the value was greater, strictly greater. So I'm just going to do a greater than sign, no equal. And I'm going to go and compare it against the 2014 value. So I'll just click in the 2014 cell. So that's going to be my conditional test. If the 2019 value is greater than the 2014 value, type a comma, and if that test is true, I'm going to go and write the word increasing. Otherwise, we'll do a comma and we'll specify not increasing as what it should do for a false condition. I put my words inside of double quotes, and then I just closed up my parentheses. So I'm going to go ahead and hit the enter key, and I've got my formula there, and it didn't automatically fill, but if I go to this auto corrections tooltip, here I can tell it to overwrite all cells. And so you can see it automatically copied it down there, or I could have used the autofill handle to drag it down as well. So you can see that some counties had increasing, some counties were decreasing, like Webster County. It dropped by more than 2/3. In some cases here, it was 0, and before it is 0 in the most recent year, so it's still not increasing, even though it really just stayed the same. So far, we've used if statements with a simple conditional test just to compare the value in a cell against a fixed number. We've used the if statement to go and compare the values in two cells. And we used an if statement with the OR function to go and have multiple conditional tests. Another thing that we can do with if statements are have what are called nested if statements. This is where we go and place if statements inside of each other. And this is going to allow us to have multiple potential outcomes rather than just what we've seen so far where we do one thing if it's true and another thing if it's false. Let's head over to the prices sheet, and we want to go to column L here, this coal pricing column. And we're going to determine basically what the pricing was, relatively speaking, for a county. There's going to be three potential outcomes here. If the price per ton was at least $100, we're going to say the price was high. If it was between $75 and $99.99, we're going to say that it was moderate. And if it was less than $75, we're going to go and say that the price was low. So we have three potential outcomes. Let's see how we can write this. I'm going to start off by going and putting in an equal sign. Since we have a formula here, we're going to go and call the if function. For the first logical test, I'm going to check to see if we meet the threshold for the high price category. So what I'm going to do here is check to see if the 2019 price, I'm just going to click in the cell there, was greater than or equal to 100, since we said that we want it to be at least $100 to qualify. If that's the case, I'm going to display the message high. If that condition is false, this is where the nested part of the if statement comes into play. We're actually going to write another if statement that's going to be evaluated in this situation. So if the price is less than 100, which is what's going to happen if we get to the false case here, we're going to evaluate this second if statement here. And this time I'm going to check to see if we are in the moderate price category, which we said was between $75 and $99.99. We know in this case, because we're in the false condition, that we're not greater than or equal to $100. So I actually don't need to test for this condition again. I can just check to see if we're greater than or equal to 75. Because if we're at the point where we're running this if statement, we know that we have to be less than 100, because otherwise it would have just wrote high out already. I'll go ahead and click on that cell again where I have the 2019 value, and I'm going to check to see if that is greater than or equal to 75. If that's the case, I'm going to go ahead and write moderate. And if this one is false, we're going to have a price that is less than $75 per ton. We can just go ahead and write low. I don't need to go and have another if statement to go and check things. Basically, as long as you have sort of mutually exclusive categories like this, when you go and nest if statements, you'll have one less if statement than the possible number of outputs. So we have 3 possible outputs with high, moderate, and low. I have 2 if statements here. We go ahead and hit enter. We'll see how things go and propagate. So these counties here where like the average was 72.70, that was a low price. This one here was in the 75.64, and this one here was like 85.42. That fell into moderate. The ones that were over $100, like we have Greenbrier County here, and we have McDowell County here, and Randolph, those ones are marked as high. Wyoming is high as well. Having nested if statements like this works out as the way to go and be able to handle multiple possible conditions. Just be thoughtful about how you go and structure your nested if statements so that you can try to have the simplest possible rules. So like here where I'm doing this fall through, where if it's less than 100, it goes to false. I don't have to check to see if it's less than 100 again. That's just going to allow you to write a little bit less complicated rules. It'll be easier to understand what's going on. Here in column K on the prices sheet, we're going to classify each county based on the rank of its coal price. We'll use a series of nested ifs for this as well. Let's go ahead and start off with an equal sign in our first if. And we're going to have 3 possible outcomes for this one. If the rank, which is in column J, is not more than 18, we're going to say top third. If it's between 19 and 37, we'll say middle third. And if it's 38 or greater, we're going to say that it's bottom third. So for my first condition here, I'm going to check for that top third scenario. So it's not more than 18. And let's go ahead and grab the rank by just clicking that cell. Not more than can be translated as less than or equal to. So I'm going to check to see if that's less than or equal to 18. And then I'll type a comma. If that's true, Inside the double quotes here, I'm going to write top third, and then we'll do another comma so I can specify the false condition. And this one's going to be another if statement. Since there's 3 possible outcomes, I need 2 if statements to make that work. For this if statement, I'm going to check to see if it's true. It's going to be the middle third category. I already know in this case here that if I'm evaluating this if statement, the rank has to be 19 or greater, because otherwise it would have gone to the top third from the true output from this first test here. So I don't need to go through and check the lower bound on the range. I do need to check the upper bound. So what I'm going to check here is to see if the rank was less than or equal to 37. If that test is true, then I'll write middle third. And if it's false, that means our rank was 38 or higher, and I'm going to go and write out bottom third. I'm going to close up the parentheses for both if statements, and I'll hit enter. I want to make sure that I have the same formula all the way down. I'm just going to go click on that cell, and I'll press Control C to copy it to the clipboard. And then if I hold down the Shift key and press the N key and the down arrow, it's going to go and select the rest of the cells that are in that column in the table. And I can press Control V to go and paste. I could also go through and use autofill, or I could have gone through and used that autocorrect option to overwrite the values. Now, you see there's actually kind of one interesting little thing that goes on with these results here. Everything is actually top third or bottom third. Nothing actually falls in that middle third category. And that's just because of the way that rank EQ is going through and dealing with ties. We have a whole bunch of counties where the sales price was listed as the $72.70 a ton here. And in those cases, they all got ranked as 12, which qualifies as being in the top third. So our if statement is working as intended. It's just that's kind of an aberration with the underlying data that we're dealing with. Let's finish up this project by taking a look at the analysis questions. There's only one for this project, 7A. It asks us to identify several counties where mining stopped by 2019. And further, we're asked if the end of mining in those counties means that there's no remaining coal deposits. So let's go and take a look at our coal mine data here. And we want to find some counties where mining stopped by 2019. So it looks like we had that happen with Braxton and Clay and Grant and Harrison and several more, but those are a couple for us to go through and list here. So we'll go and say examples of counties where mining ceased by 2019 include Braxton, Clay, and Harrison. And then we have the second part of basically, does the fact that we're not mining in those counties anymore means that there's no coal left? And let's think about this here for a little bit. Depending on what we need the coal for, there's actually several different types of coal. Biggest difference is between metallurgical and steam coal, but there's different grades and categories within those types. And coal is something that we're mining here. It can be from underground or from a surface mine, but there's costs associated with that, and different locations are going to have different costs associated with doing the mining. You know, if it's a case where I can just go take off a little bit of soil from the top and then get to a 10-foot seam of coal, that's probably going to be cheaper than if I have to go and blast off the top 300 feet of a mountain to get to coal. With that in mind, the fact that we stop mining for coal in an area doesn't necessarily mean that all the coal's gone. It's just could be that it's maybe not economical to mine that coal anymore, or at least there's other areas that we can mine more cheaply and still meet all of our needs without having to go into more expensive locations. So let's go and write an answer that reflects that. So we'll say the end of mining in an area doesn't mean that all of the coal deposits are exhausted. It may instead just mean that the coal remaining is no longer economically feasible to mine. So I think that's an answer that's going to work for what we need with this analysis question here. At this point, we're done with our project. You'll want to go save your work, close out of Excel, and then submit this participation project through the CS101 website.